Good morning everyone, my name is Surya and I am from Young Tinker. Today we are representing the team Marvel and I am 10 years old. We selected the team Marvel because we marvel in our work.
And then Marvel always works in a team. And hello, my name is Ranesh and I'm 11 years old and I'm a young tinker.
Hello, my name is Krishna. I am 10 years old. I am from the team Marvel and I am a young tinker.
On day 1 we learned about the basics of aerodynamics, where we learned about air resistance, drag, thrust, and we also learned about lift. We also learned why streamlined body is very useful because it helps us go faster.
And we learned about the Newton's 3 laws. The first law is law of inertia. If my sister is watching TV and if I tell her to bring some water, she won't get me water because she wants to watch TV. That's the first law of Newton. When an object is in motion, it tries to stay in motion. When it's in rest, it tries to stay in rest. And the second law is law of acceleration. It is F is equal to m into a. Force is equal to mass into acceleration. And the third law is every action has an equal and opposite reaction.
Streamlined body is very important in going fast because it reduces the air resistance of drag. So this helps us going faster. Examples are submarine, aeroplanes and rockets.
We also learned how aeroplanes, helicopters and rockets work. So me and my friends are going to talk about different means of air transport and how they work. I'm going to talk about aeroplane. So aeroplane flies by going very fast and hitting the wings. So when the air hits the wings, the air bends downwards and the aeroplane flies upwards, which is the third law of Newton. Every action has the same and opposite reaction.
Helicopters work when the blade starts rotating, it pushes the air down which results in the helicopter going up. And then this is the third law of Newton. Every action has an opposite and equal reaction.
Rockets are different from the others because they burn fuel and they turn the fuel into fires. But even this action uses the Newton's third law. Every action has an equal and opposite reaction.
And talking about this, we also made our own helicopters on day 1. So I'll be showing from the largest to smallest how the helicopters work. That was the largest helicopter. So if the helicopter is large, it goes slower. This went faster because it was a little more smaller than the before one, and this is more smaller. And this happens because of air resistance. Because when the blades turn, this is because of air resistance. So the less the air resistance, the more they turn. So the less the wings, if you chop off the wings, the less the air resistance and it turns faster. So I chop this off and this goes the fastest.
And we also learned about design thinking. What is design thinking? Design thinking is how you think and design. The first step of design thinking is empathize, where you think from the user's perspectives, which is us.
The second step is define, where you find out the problem, like for example, how to make a rocket that can go up to 50 feet.
And the third step is ideate, where you have to come up with a lot of ideas, and there can be 10 or hundreds. So you have to select one among them. And the formula to this is DMW. This formula stands for D for doable, M for moneyable, W for wantable. Doable means that if you can actually do it and you have the resources to do it. Moneyable means that if you have the money to buy all the resources. And vulnerable is that if you can actually win the hearts or satisfy the users, which is us.
And then we chose 3 types of different materials for the rocket's body, which are wood, metal and plastic. We didn't choose wood because the wood adds a lot of weight to the rocket, and we didn't choose metal because it also adds a lot of weight, and then it can burst because of the air pressure. And we chose plastic because it is not heavier, and then we chose plastic bottles because it's already in the desired shape.
Step 4. Prototype. Prototype is when you make a model just like the main one to make sure what type of model you have made.
The last step is test, where you need to test the model and see if it actually works. And if it doesn't, you again have to go to the part where you had misunderstanding.
We made launchers for launching the rocket. We used 3 materials: connectors, glue, and pipes.
We made this because it's the most stable design we can make, and then we used couplers to not let the air outside.
We used industrial glue to make it harder. We didn't have a very stable design, but after we checked, we made a very stable design. So now if you bend this side, it supports, and even this side. So we used industrial glue for PVC pipes because to make it airtight and watertight because of the pressure. We also used a ball pin. Board is a thing which is like material which is waterproof. So even if the water falls on it, nothing happens to it. But then when we saw, the sunboard was making the rocket heavier and it didn't let it go higher. And we used this pump to like launch it, and then there were 2 pins, one for the bike and one for the bicycle.
We used a bicycle.
And now I'm going to say what happened when we launched the rockets. The observations were when we kept the fence, it didn't go much higher, but then it went very high because of the fence. With the bigger quadrant, it went high, but not the smaller one because the nose was smaller. The nose was very small and the water was leaking out. But for this, the nose was very small, so it wasn't leaking out. The nose was very big for this. Yeah. Thank you.
Thank you.
Sir, I am sorry.
So 1 second. Monkey.
3, 4, 5, 6, 7, 8, 9.